So today we'll talk about the SYN flood attack. So as means of denial services, but before we can talk about that, we have to touch on the mechanism of the some TCP three-way handshake first. So let's take a scenario where we have got two machines making a connection to the machine 1, and in this case it's going to be the attacker and machine 2, which is the case will be the victim. Now within the TCP protocol there is an initial handshake between this machine, and what happens is the handshake of first machine sends a synchronized request, often referred as a SYN. The second machine then acknowledges that and sending a synchronized acknowledgement response. So you usually see that as referred to as SYN. All going well, then the first machine will come back and send an acknowledgement and act the responses, and this will be the three-way handshake that have now established a connection together. This is pretty much TCP 101, and which is the fundamentals and how the protocol works. So let's move on through and see how it can be exploited in a SYN flood attack, and so that we will be start the way the same as machine. So machine 1 is sending the SYN, machine 2 is sending the SYN and then nothing, and it just waits and nothing actually happens. So the target is sitting there waiting for the response from a machine 1, but it never gets a response from the machine 2, and machine 2 doesn't know if it's the network latency, so it could just take a while for the response to come back. Now the problem with this is that the connection of the target machine is left open. So until it decides that there is never going to be a response and move on, but within that time the first machine may be sending multiple other synchronized requests to the target. So the whole thing is that the volume actually makes the situation worse and worse. So this is the another volumetric attack, is just at the layer of 4, so that the fundamentals of a SYN flood attack, but it can also be ramped up a bit. So let's look at this way. We have a machine 1 and which seems the SYN, but also spoof the source IP address. Now that means is that the target machine is now going to send a SYN and back to a totally different machine. So now we have got a target machine also targeting another machine, which is the one of IP address with the original SYN request. Now one reason the attacker may do this is to give them the obfuscation of a created degree of anonymity as to where the attacker actually is originating from all of this again. So is this layer 4? Let's now move on and take a look at the couple of layers, or take a look at the variants of a SYN flood attacks. So direct SYN flood attack, which is the case of a attacker start the SYN flood attack under their own IP address. So in order to ensure that incoming SYN or ACK packets are discarded, the attacker configures the firewall of their machine accordingly. So another approach is to limit the network traffic from outgoing SYN packets with a spoofed ID. Attacks with a spoof ID address are more common. The attacker enters a fake ID address in the center field of a SYN packets, thereby obscuring their actual place of origin. Attacker prefers IP addresses that are not in use, and at the time of the attack they ensure the accidentally affected system do not respond to the SYN or ACK responses from the attacker server with an RST packets, which would thus terminate the connection. DDoS SYN flood attacks, and full form is distributed denial of service SYN flood attacks. So in these distributed attacks of variants of the SYN flood, the attack is carried out simultaneously of many computers. It is usually a combination of hijacked machine called a botnet. The botnet zombie computer are under the control of the attacker and then send a SYN packets to the target of their commands. Reflection SYN flood attack. A server usually responds to a single SYN packets with a multiple SYN or ACK packets. An attacker could take advantage of this and trigger a reflection SYN flood attack. The attacker spoofs the victim IP address and starts a DDoS SYN flood attack against one or those uninvolved servers, and the victim machine is bombarded with a flood of SYN or ACK packages and collapses under the load. So let's look at some of the rules of protect against SYN flood attack. The SYN backlog mentioned previously in the part of the operating system. So conceptually you can think of a SYN backlog as a spreadsheet. Each line contains the information of establishing a single TCP connection. The operating system the first manages the connection, then only a connection has established by completing the three-way handshake is it then passed of the application waiting at the port and then removed from the SYN backlog. A related approach is to delete the half of a connection from the SYN backlog when it is full. This creates space for a new half open connection. So in combination with a large SYN backlog, the approach can lead to a system remaining accessible during a SYN flood attack. However, this method is ineffective for high volume attacks. The idea behind a SYN cache is very simple. Instead of storing a complete TCP in the SYN backlog, for each half open connection only a minimal TCP is kept. The technique uses cryptographic hashing to prevent the attacker from guessing the critical information about the connection, and the SYN cache has proven to be an effective connection data can only be lost in a few special cases. The fight against DOS attacks is an old and as the internet itself. So, however, modern attackers have far more firepowers than the disposal thanks to the botnet. The resulting DDoS attacks with their enormous flood of data can bring even the strongest system to their knees. Therefore, the service of large globally distributed cloud providers are increasingly being used. So, snow lorries isn't attacked that referred to as low and low, and we are talking about here is using a low volume of traffic to generate a slow rate. So let me explain what I mean by that. The attacker is going to send the HTTP request without the termination sequence. So what it happens here is that the target website going to be sitting there leaving the connection and open waiting for the connection to be complete, but it never does complete, and the target machine just sit there waiting and waiting and waiting for the resource allocated just for the termination sequences, but it never arrives. And the thing about the snow lorries attack is that everything can actually originate from a single origin, because if the single origin can send the partial request and then sending them and resending them, the target just then sit there the waiting for a request that never arrives, that can be enormously burdensome for the environment. Then it's going to be very difficult to proceed the legitimate request whilst it goes all the connection open. Let's have a look how it would work in a diagram. So Snow-Loris is really straightforward. We simply have one machine sending an unencrypted HTTP get requested to another machine, and then it keeps sending them the target machine, and the target machine just sits there waiting for the request to be complete, but it never is. So that's the Snow-Loris connection in action. So let's get to a quite different and topic than this is the DOS and flashing.